My name is Yuri Pidvalny. I'm working as a simulation engineer for Mercedes-Benz, and I'm extremely excited to present today. Together with me, my colleague Matthias Spath. He is project manager and logistics planner at Düsseldorf plant, where we produce those beautiful sprinters, which you can currently see. So big thank AnyLogic for having us here today, and let's get it started. The topic today is a simulation as a process optimization tool in automotive intralogistics. Before we go into details, let's just talk about the motivation. Why did we have to create the simulation model? And the story is following. Our engineers needed a tool to assess and optimize the efficiency in context of wide HGV implementation. And in our focus were following efficiency aspects. Amount of equipment used, as well as amount of any other resources is of course important. Pooling of workforce, especially if we're talking about irregular tasks. Non-productive time were in our focus, and examples are traffic, when some vehicle is blocking other vehicle or just slows down. There may be some waiting time along the processes. There is some repacking activities that can be avoided if, for example, vehicle arrives too early to the assembly line. Traveling distance is important because facility is large and traveling is a big part of activities. Stock reorder levels, delivery tours utilization, and above that all is, of course, the fact that we cannot afford having assembly line shortages. So we always keep an eye on the fact that every delivery should be delivered in time, and when part is not there, it's just too expensive and it's not accepted. So let's now look into the challenges that our logistic planner has if he wants to do his job better. So the first thing is long list of components. We are talking here about tens of thousands part numbers assembled in the same plant. Of course, there is a high variability of features, and the example of external mirror for Sprinter, which we are offering in 130 variants, should be quite compelling. Complex and numerous methods of delivery to assembly line. That's just coming from the fact that our part numbers are pretty much different from each other in terms of size, in terms of weight, volume, handling, and packing requirements. Restrictions of space and time. Here we just mean that facility layout is not something that we can easily change, and pathways are shared by different types of vehicles. And time is very critical, as we already told. Every delay can lead to a production line halt, which is not accepted. Complex assembly line requirements, and that's where we understand that our assembly workers should work extremely efficient, and there is a so-called one touch, one motion policy, purely meaning that it's only allowed to do one movement for production guy to take apart, and so he's not doing unboxing or he's not searching materials. Let's now that we've looked into challenges and complexities, let's now talk about the selection of a right tool. And this question kind of splits into two. Why simulation at all? And here we see that our processes are quite complex. We have a lot of different processes, actually around 15 of different processes, and they are interlinked with each other on different levels. First level is a just direct process level where you cannot get part until it's not processed in another process. Second level is that all the processes are sharing actually the same layout, same streets. They are impacting each other through slowing down or even blocking. And the third level is shared resources that we are using for different processes. And on top of that, we have a stochastic demand for our part numbers, and all of that together just making it impossible of usage of any static tool like Excel or anything similar. And then why AnyLogic? Before starting this project, we had the following requirement, that we wanted to have a discrete event simulation framework with a strong material handling functionality, with the support of programming language for custom developments. Usage of external libraries was a must. Of course, we don't want to invent a wheel every time. And Simulation Cloud for collaborative experimentation. That's just because nowadays we all love clouds. And
it's a very brilliant feature for me as a user to be able to access something via cloud that Yuri has just programmed. So sharing the program and the information just gained speed, which is incredible.
Right. And now going into the a little bit more technical details about the architecture and our modeling approach. So our guiding principles were following. We wanted to create it as a flexible tool, scalable tool. We wanted to enroll it in other plants as well. Always actual data should be feeding our model, and quick adaptation to changes, just because we are talking about quickly changing environment. And therefore, we have those three blocks here. The first is about layout. The facility layout is important for the simulation, and we implemented this as a parameter. That literally means that Matthias, as a logistic planner, he uploads CAD file to the experimentation if he wants to try some new ideas about some small changes in the layout. Number two, very low abstraction level. Here we are talking about every part number at every location, all transporter types, resource pools, order pools, shifts, and a lot of more information being extracted from production system in a CSV format. And in this way, we have very detailed and very actual information fed to the model. Third thing here, modular design. Of course, as we've heard a lot today, AnyLogic is providing this object-oriented programming approach where we can make everything as a classes and then just manage. And in this particular cases, we created all our process as a kind of a box of library, and then we used kind of in a master model, we are able to distribute our orders through different processes in a way that you can see here at this slide. And for every new implementation, it's just a matter of selection right processes and maybe quick adaptations of one or another process, and the implement and deployment time for new simulation for new plant decreases dramatically. Now, that's the slide where we can see all our processes that we simulate, and every process has its own process flow chart. Of course, we have a lot of them, and most of them was probably a separate presentation. But what we have at the end is one big meta model, which has a lot of small models kind of embedded in it. And that's how the model is designed. Now, I propose to look into the simulation in the runtime. I start the video. Now we see that we have been using private cloud. We have a lot of parameters, and we also see the layout here, CAD file as a parameter. Now we start simulation and see that first of all, we see our facility with all the locations. Locations are highlighted with different colors according to the state and functional purpose. And actually, in this layout, every location is clickable, so you can the user can click and see all required information. That's very useful, in particular for during troubleshooting and validation. Yeah. What we also show here is a density map feature, which can be really helpful for the purpose of validation and finding bottlenecks. 3D animation is a very powerful feature if you want to present your model in particular to your management, and probably indeed you cannot find any better way to explain how things work if it comes about things like logistic processes. You may probably ask whether it's a big effort to create such an animation. It looks like, at least it looks like that, but in reality, it was just about two 3D objects. One is the object of this vehicle, which we obviously had, and another is a 3D object of environment, of a plant environment. But both were retrievable from some internal systems, and we have integrated it as a model that was easy. And now we see the example of a process, and let's now kind of check how powerful is this animation as a tool for understanding. This process called car sets, and it may be a little bit difficult to understand the meaning, but you can think of it as a personal shopping. So those three pickers are picking cards for individual vehicles, and every card containing 30 to 50 part numbers for individual vehicle. And once they're picked, they are placed on AGV, and then AGV is transporting it to assembly line. So already in this process, you may see some inefficiency. That's an example which I wanted to show you. Once they're ready with the picking and they are kind of put away their cards, they are just idle for some moments. And why are they idle? Because this AGV is kind of late. It didn't arrive here yet with empty cards. And why it didn't arrive? Because this location was occupied with this one. So it's just a matter of placement of AGVs, locations of their waiting positions, or maybe number of AGVs. And we have been able to identify it and quite easily fix. There were a lot of things where we've used this animation in order to understand and find better solution. What else? We can also see some internals of the model, kind of how Ben Schumann was sometimes saying, looking under the skirt of the model. So that was an example of a forklift process, quite an easy one. This one is a convoy process, a little bit more difficult because it contains of 3 different sub-processes. And the next one, which will be shown, is a car set process. As we already seen, it contains of 3 main components: picking of those car sets or shopping carts, AGV movement, just the transportation from picking area to assembly line, and the consumption of those car sets at the production line. Now we are slowly moving to the results and outputs. Of course, we generate a lot of output here in this model. We have detailed information about the resources. For example, here you see resource pool utilization over time for convoy driver, and you can even see the breakdown of activities. So very detailed information about how what was its utilization. And there are much more information about order pools, intermediate locations, some time plots. Actually, we've provided all possible outputs that could be useful for our users. Yeah, and now I guess I have to. Now it's time for Matthias to take over and to tell you a little bit more about the output and results.
Unmuted first. That's what I've learned so far during Corona. Thanks, Yuri. And thanks also for all the programming with that. If I introduce myself a second time, I'm kind of the customer and maybe a little bit of a developer, because data input is always a crucial factor in simulation. So responsible for data input and seeing what's coming out. So what have we achieved so far? with the simulation, we're able to show results that we could not see before because of the discrete event-based simulation, and we're able to have it on a level which is more detailed than ever before. So if we're talking about resource utilization, usually, of course, we're doing a static calculation, but the static calculation can't show it on the same level of detail, and we can't see the time we're stuck in traffic and so on and so on. That's all an expert guess when we calculate it roughly. But in that case, we can see utilization by activity type. So how long does it take repacking? How long is he handling a container? And how long is he actually driving? Also, for the first time, we're able to see the real traveling distance. For a forklift, it's not too difficult. It's connecting A and B, and it's always one container. But for a tow tugger train, where you can take 4 containers to 300 plus possible locations, we never knew what's the average way he's actually taking. So the simulation is showing us that as well. And thanks for Yuri for his brilliant TSP solving algorithm. And it's now up to our workers to do that in their heads. We can see the amount of containers per shift, location, and route. We can see the utilization of a route. And I'm not talking about a human and how long is he spending work, but we can also see the utilization of the equipment. So imagine you have a truck and the truck driver is always driving. So it's not only important that the driver is always busy, but it's also important that the truck is always full. So we get a measurement on how efficient is the driver and how efficient is the vehicle used, which is another nice feature. Of course, we're looking at the assembly line shortage. It's our main duty to keep the line in production. So there's no missed part at line side ever. Like Yuri said, we can't afford to stop production line. The criteria is in there because usually it never happens, but we want to use simulation as an optimization tool. So we need to have a look at the assembly line shortages. If we stretch optimization too far, it might be too far. So maybe it doesn't work and we get a shortage and then we need to get rid of it again. But then again, the results are on a part number level. So instead of hiring extra people to transport material, we can just say, let's increase stock for this specific part number out of the 5,000 part numbers we simulate to get rid of that shortage. And then we can actually turn exactly the right screw to realize the potential it generates. So what else is brilliant about this project? Basically, I can get every result I wanted because of the feature that Yuri can have personal adjustments, or he's able to program the simulation or the outputs the way we require. And I think the more we use it, the more output is going to be generated. And it's just a growing project. All right. So talking about all the outputs, how are we using it at the moment? So first of all, we said we're going to use it in 3 steps. The main goal was to automate and to implement AGV tracks, check the logic, check the weightings position, and verify that everything is working before we actually spend the money and place the order. And we're talking about a 7-figure order number here. Quite expensive project, so let's verify it before we actually buy it. But the first step we now are using the simulation is efficiency assessment for the manual process. The simulation shows quite clearly which worker for which task has which, how high is his utilization level. So it's a possible quick win that we can uncover. We can see if we can work that has been split up amongst 2 people where we never had the courage to combine it because we were unsure if it's possible or not. The simulation can prove it and we can have an efficiency gain there. Also, it optimizes my planning because it does about 90% of the calculations I normally do manually. So it's a very nice tool for efficiency assessment in the manual run. In the second step, we are using it actually for the AGV implementation. So we think about where is optimization potential. We think about how many vehicles do we need, the control logic or the logic the transport's taking place. And we also get the correlation with the manual transport. So it's not just distance divided by speed that is actually determining the time, but it's also, are we blocked alongside the way? How much material is placed alongside the way? Can we drive past the obstacle? And so on and so on. And we're using it as a regular tool now to verify our investments before we spend the money. Plus, third use case for the simulation, because we can manipulate the input data and pretend that everything is automized. We can check whether or not is the logic working. Are we calculating the right amount? And it's actually a good mix between 2 and 3 that is going to happen the next couple of years, where we check how could everything be automized? Is that the right order we're automizing, and so on and so on. Talking about numbers that everybody usually is interested in, we have simulated a workforce of more than 70 people in the first run, and already in step 1 we had an efficiency gain of about 5%, and in step 2 we already realized the next 5% from automation. So we're using it, or the plan was to use it daily to have up-to-date data, to have the model flexible, and so far it's working quite well. And as a user, I can say that the cloud offers a great opportunity for me to look at the simulation, and also a phone call away, Yuri is sitting and he can adjust it, and I have an update straight away. So it makes work quite easy. So that was it with the presentation, and I'm already looking at the questions at the side. So thanks for having me and giving us the opportunity to present to you what we've done during the last year. And also we answered first question with that.
Thank you for that, guys.
Yeah.
Yeah. How long did it take you to make this model? I think that was the first question that came up.
Yeah.
Very impressive.
I would say there was kind of half of a year of a work, of a hard crunching of the code, and then after that several months, but dedicated purely for testing, validation, and the ideas for fine-tuning, and some additional requests which are appearing on the go.
Lucky we had sprints.
Yeah.
The refactoring that we heard of
earlier. Yeah.
And I spend, I don't know if I would have a guess, because I'm doing this kind of part-time, and I also have my other projects that need to be running. I probably spent 2 months on having a correct input data. So getting it from the system, reworking the input and seeing what's happening, and making sure that we can apply the changes we wanted it via manipulated input data. So the programming is one part, and then I don't know if the conference is the right place to say this, but we used to say shit in, shit out. So we have to make sure that the data that's coming in is all right as well, which is quite a lot of work.
Did you validate it on many sets of previous data?
Yes, we checked the simulation output versus the manual calculations we do. And we always had a plus, minus, or pro contra sheet saying, all right, the simulation is more accurate, or the simulation is not that accurate, because we kind of abstractly build it for this specific process. So we went down as detailed as necessary. You can still go even more detailed, but then again, the effort you would have to take would not match the output we generate. So we decided to keep it at some points on a not a low level, but on a not so detailed level.
And what kind of decision process would you go through when deciding whether you wanted to refine it a bit more, or whether you were at a good enough stage?
But usually I compare to the manual result and to the calculations I do, and then I check, actually walk on the shop floor, see how the process is done, and compare it to the 3D visualization. And then you can see the biggest distances. And then up to that, it's more or less for the workforce to decide whether it's detailed or not enough for them. And then maybe they have an additional request, and then I present it to Yuri. But usually we went along quite well so far.
Great. And the second question we've got here, is it possible to do parking simulation for trailer type vehicle in AnyLogic? That's a question to be pointing towards the developers.
I would.
Yeah, of course. I don't see any impediments.
I would have a question back, because forgive my bad English, the German would be Höhekurvenanalyse. So the track he's taking and everything he needs, the amount of space and so on, and there is better tools than AnyLogic. Sorry for you to say that, to solve that problem, but to make sure that a trailer is always parked at the right time and how much time it takes, I would say it's definitely possible. Depends on whether you want it on the restriction of space and everything. There's specific logistics tools for that, but yeah.
Another quick question. How long does it take to run the model for a working day?
Yeah, good question. The performance of it is quite quite good for experimentation. It's running with a speed of 3 minutes per second. So 3 minutes of model time running in 1 second of real time. That means
Okay.
you need around less than 10 minutes to simulate a day.
That's cool. Okay, we've got some more questions coming in as well. So somebody's just asking if you could clarify, how did you get the efficiency gains? They didn't quite catch that part.
Okay. How do I say best? I have one guy who is an 80% utilization level, another guy who's on 60, and another guy who's on 50. So it all adds up to a bad example. Let's have 3 guys, and every utilization level adds up to, if you add it up, it adds up to less than 200. But you were not sure whether or not you could combine it because the tasks happen irregularly. And if they all happen at the same time, you can't pull the potential. If they don't happen at the same time, you could. And then we actually fed simulation with it. We get we simulate, I don't know, 5 to 10 different experiments with different demands and requests. And we said, all right, is this happening or not? And if then it doesn't show a negative stop, we actually can pull the potential. Also, it's the question of connecting pathways that always add up on extra. And we can realize that. And then it's also, I have to go quite on a low detail level. If we deliver a container and there's not enough space at line side, and we ordered 100 parts, the guy arrives and he has to repack 80 parts. So he spends a lot of time repacking parts and filling up the other container. If I order at a lower level, so at 50, he has to repack less. So we played with the level when we placed the order, decreased it, thought about a formula to have a smart way of calculating at what time we should start. Also, the simulation output gives us exactly the duration it takes to deliver a container, so we can fine-tune those settings as well. So we played around with a lot of input settings and then fed the simulation with it, checked whether or not it's working. And if the simulation says it's working, we try it as a small part in real life. And if a small part is working, we go into the big part. And so far, it has been working quite well.
Fantastic. We're beginning to get close to the end of the hour and half hour, and there's several more questions coming in. I'm going to just pick 1 or 2 more out, and then I'm going to encourage people to catch up with you on the platform. There's roundtable discussions there for people to catch up in groups, and also direct messages and other ways of contacting each other. But a quick one that maybe won't take too long to answer. So roughly how many people or departments became involved in such a project?
We presented it to, I don't know, 20. Involved in the development was actually Uri's department and mine as a main responsible. And then I would say as a third department, or 4 maybe, our IT department, because I had a lot of requirements to change processes. And the operative people on the shop floor and their bosses were mainly involved in building up belief in the model. Let's say, let's call it that way. Because if you come with efficiency, it's always hard to argue with it. But then again, 3D simulation, perfect tool to show it to people. So there's not any gain in efficiency or input for me. But if I want to show the model to someone, this is the way to go.
Becomes very easy to start
Yes.
presenting it to a lot of people, I guess. All right. Thank you very much, guys. Thank you very much for coming along, and thank you very much for the presentation.
Thank you for AnyLogic for
Thanks.
having us.
Thanks for having us.
All right. Take care. See you on the forums. Okay. Bye-bye.
Ciao, ciao.
Bye.